Hey, you guys. So we are in the last part of this unit where we're learning about phase changes and what that means. So you've done an investigation where you looked at dry ice, a virtual investigation, and different things that dry ice can do. Then you watched a video that talked about liquid nitrogen and the kind of the cool things that happen with liquid nitrogen. If you were in class, you would honestly get to play with all of that stuff. But right now, we're really learning our tech skills and how to pull information off, whether we're looking at a video or just trying things at home. So today, we are going to take that information. We're starting to process what the different phase changes are called, what happens whenever heat is added or removed to a system, and we are going to be getting that into a set of notes. So right now, I am going to present my screen, and I want to show you guys where this can be found, this handout that I want you to get to in Google Classroom. So whether it's second hour or sixth hour, it's going to be in the same spot, but you're looking at your top bar, and you're looking under the reference materials. So this would be above, if we scroll down, these are all the different dates, but you're looking in Unit 2 reference materials. And what I'm wanting you to pull up, if you have the ability to print it, fine. If you don't, then you could just make a copy, and you could, or you could even do this as notes off to the side. Okay, so don't let the fact that you don't have a printer be something that keeps you from doing this. So you could just have this as a document, but then write notes in a packet or in your notebook off to the side. But this is the handout that we're going to be looking at today. And we're going to be filling in this very first part. So whenever you see me doing a drawing here in a bit, I want you to put the drawing on this very first page if you do have the ability to print it out. So on page 1. Otherwise, you could just write this on some piece of notebook paper that you know is for your science class. Make sure to file it good so that you can come back to it. And what we're going to be doing is listing out the different phase changes and what those things are called, and which of those phase changes do we add energy to for it to happen, and which ones do we take energy away for it to happen. So if you need to press pause for a second in order to get that printed or just get yourself a little organized, then that's completely fine. And whenever you come back, let's get ready to fill that in. So again, we are kind of skipping the states of matter that's called plasma. We're really focusing on those states of matter that we see in general here on Earth, so solids, liquids, and gases. And on that first page in this new packet, I really, and you're going to get to use the entire first page to do this, but I want you to list out, and you're going to, oh boy, none of my markers are wanting to work right now. I want you to write solid. I'm going to see if I can get a marker that works better than that. Hold on one second. Yes, so let's see if this one's, there we go. So I want you to list out and write solid, and then liquid, and then gas. So solid, liquid, and gas. Okay, and I want you to add arrows going down to each. And then don't forget, I want you to put an arrow also from a solid going straight to a gas. And then let's add arrows going up to each. And same thing, gas going straight to a solid. What I really would like for you to do right now is to push pause on the video, and you can use a pencil if you want. But right now, before you even listen to what I'm about to share with you, I would like for you to, on your own, create it as an exercise. What is it that we call a solid going to a liquid? So, and I like to use the water as my example whenever I'm thinking this stuff through. So I go, okay, solid water, what is that called? That's called ice. Whenever ice turns into a liquid, what do I call that? So I'll go ahead and write it in this first time to spark your mind a little bit, that this would be melting. Okay, so whenever solids turn into a gas or a liquid, it melts. So hit pause and see if you can fill out all of these arrows. See how many you can fill out. and then hit play again, and you can check to see if what you came up with is what I came up with. So if we continue on this, whenever a liquid turns into a gas, there's really, in general, we call that vaporization. So I'm going to write that. That might be a new fancy word that you're being introduced to, vaporization. Okay, but, and this is getting maybe a little messy, but that's all right. Vaporization, I'm going to move this down just a little bit. There's really two ways that we can talk about this, and it can be through boiling. And that might have been how you were thinking when you think, oh yeah, when water turns into a gas, we boil it, but it also could be evaporation. Okay, so boiling or evaporation. Okay, when we look at a solid going directly into a gas, this is called sublimation. So those are all of our down arrows. Melting, vaporization, and sublimation. Now if we do the opposite. So if I look at a gas turning into a liquid, this is called condensation. Okay, condensation. If we think about liquid water turning into solid water, so liquid water turning into ice basically, this is freezing. And then if we think about a gas going directly into a solid, like frost forming on the mirror of a car in the wintertime, it's depositing. This is called deposition. I like to write it with arrows because one of the things we want you guys to catch is which of these would need heat for them to occur and which of these would need heat to be released and then they get colder. Now, if we think about this, all of these that are pointing down, I would have to add heat to them. So I'm going to kind of highlight them with a red arrow. And I know that heat has been added because the end result is always warmer than the initial. You know, liquid water is definitely warmer than solid water. Gaseous water is warmer than liquid water. All of these need heat added. And so that's why I really like to use arrows for that to happen. We have to add heat for those things to occur. And I should, you know, when we think heat, we really want to think energy. Okay, so heat, it's kind of a scary G right there, but energy. Now all the rest, these other arrows, heat has to be removed from the system for them to occur. So a gas turning into a liquid, excuse me, my daughter just slammed the door, hold on. Or a liquid turning into a solid. So whenever you think, you know, water, liquid turning into ice, for that ice to happen, somehow that heat has to be removed from the liquid water for it to occur. So I'm going to put an up arrow here for it to be blue. And the reason I'm doing that is the final product, a gas to a liquid, well, that liquid is going to have a lower temperature than the initial gas. Oops, sorry. Same thing, the liquid water has a warmer temperature than the solid water is ice. So we had to have heat being removed somehow for all of these. So, and when you think heat, think energy. Heat or energy removed. So what I really want you to catch from this is there are 3 phase changes, all my ones that are drawn in red, that energy has to be added to the system for them to occur. And then there are 3 phase changes, condensation, freezing, and deposition, where heat energy has to be removed for that phase change to occur. So that might be kind of a new concept. There's also going to be some newness in a few of these terms. Probably deposition might be one we're not as familiar with. Sublimation might be a term we're not as familiar with. But those are things we want you to become familiar with over the next couple of days as you get prepared to come to the end with this unit. Now, I'm going to use something to kind of show you an example of how to think about this. And let me go back to my other camera here. So I brought with me, all the way from Wisconsin, down to Texas, a beaker of water molecules. Okay, so you can see hopefully that there are, I got the sun being very reflected in here, but I've got water molecules in here. Some of them, I'm already losing some of them. So these water molecules are kind of special in that even this model is magnetic. So I can use these molecules to represent the different states of matter. And whenever water is in the form of a solid, those water molecules really like to bond to each other. They might be shaking a little bit in place, but nothing that I can really see that well for them to do. But how could I get these water molecules that are acting like a solid to behave more like a liquid? Now think, liquid molecules, they like to move around each other. So if I add energy, and remember those things going from a solid to a liquid, you have to put energy in. So I'm gonna let my hands give this more energy. So now whenever I give it more energy, I'm gonna have a few less here, I can now, at least in my hands, feel them moving around each other. Oh, I lost one. Oh, lost another. And they're now not bonded together as a solid, but they still are interacting with each other. And I gave it more energy than just holding it here. Here my hand is not giving it a lot of energy at all. But when I add energy to it, now it's turned into a liquid. They're kind of sliding past one another. Now what could I do to make it act like a gas? Give it more energy, right? What is it gonna do? Well, as I give it more energy, y'all, right? They're completely, very much falling apart from each other. They're all over the place. And they had tons of energy because I added more energy to it. So they're moving faster, they're further apart. They hit that state of matter of a gas. Okay, so added energy into the system. And whenever I added energy into the system, they went from a solid to a liquid to a gas. Now hold on one second, let me get a few of these. Now if I had all of these little gases that are out here, and I give them less and less energy, they're not going to be moving as much. They will eventually come in contact with each other. Okay, so they were moving really, 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 really fast, less energy, coming in contact with each other, still giving it energy, but now it's in the form of a liquid. Now if I give it even less energy, I move my hands even less, barely moving at all. Now they're really wanting to bond together, be stuck together, and it's forming the beginnings of ice. Okay, so even less energy. So if I add less and less energy or remove energy from it, it goes from a gas to a liquid to a solid. If I add energy with my hands to it, it's going to go from a solid to a liquid to a gas. Okay, so hopefully that's helping you start to get a feel for it. We're going to do a few things with phase changes that'll hopefully solidify it even more and get you ready for the end of this unit. Hope you guys are doing good. Take care. Get those notes put in there. And other than that, you're good to go. Talk to you later.